Chemistry, and you are watching Chem Science.
In this video, we are going to discuss one of the important topic of IGCSE chemistry. This is uses of sulfuric acid, the contact process, that is the process of making sulfuric acid which is worldwide used, and then the equilibrium conditions needed for one of its reaction involved in the contact process. So let's start with the uses of sulfuric acid, where first let's understand that sulfuric acid is one of the most important chemicals used worldwide because it has various uses in many industries, and one of the use which is very important is uses in making the fertilizers. So most important use is making of fertilizers in ammonium sulfate, and the next use is it's also used in paints, pigments and dyestuffs, also used in fibers and plastics, soaps and detergents, and one of the most important uses it's in car batteries, where directly sulfuric acid is used in car batteries to produce the power for the cars. Okay, one thing important to note down is that dilute sulfuric acid is made by adding the concentrated acid to the water and not the other way around. Now, not the other way around is that we cannot add water to the concentrated sulfuric acid to dilute it, because it's going to be very exothermic. So we need to remember that whenever we dilute the sulfuric acid, concentrated sulfuric acid is added to the water slowly by stirring it. This is one of the important point to note down. Now, most of the sulfuric acid worldwide is made by an industrial process named contact process. Now, this is worldwide process where it is industrially made on a very large scale. The raw materials needed for the contact process are sulfur, air and water. That's it. No other raw material is needed, and the sulfur required for the process can be obtained from few resources, that is underground sulfur beds. So this sulfurs can be dug out from the bed through some process, and the other other source of sulfur is sulfide ores like zinc sulfide or lead sulfide. These are the ores of zinc and lead from which the sulfur is separated, and so this is also one of the source of sulfur. And the third source is petroleum and natural gas. Now, in petroleum, sulfur is present naturally in the petroleum fractions, and it is important to separate sulfur from the petroleum fractions, because on burning petroleum or the petroleum products, sulfur may create an pollution and may be one of the cause of acid rain. So it's necessary to separate sulfur from the petroleum products, and that's why petroleum is also one of the important source of sulfur. Now let's discuss the contact process in detail. How is contact process used to produce sulfuric acid? Now here is first, it's a place, you can say a compartment where combustion takes place. Now, combustion of what? Combustion of sulfur, and air is also introduced or added in this compartment, where sulfur is added in the form of molten sulfur. Sulfur is first heated, melted and added in the compartment where air is also added for the combustion of sulfur. Now, it's necessary that we add dry air. Dry air is necessary because the other parts, maybe the humidity of air, will create problems. So dry air is needed. So molten sulfur and dry air is added where the combustion of sulfur will take place, and so the reaction of sulfur with oxygen is going to produce sulfur dioxide gas. Now, the sulfur dioxide gas produced in this compartment passes to the next compartment here. Now, next compartment here is called converter. This is converter compartment. Now converter is the compartment where sulfur dioxide is converted to sulfur trioxide by further oxidation. But this is a very important reaction because it's an equilibrium reaction. Let me write the reaction separately here, where sulfur dioxide is further oxidized to sulfur trioxide, and if we balance the reaction we need to add 2 on both sides. Now, so this is the converter where sulfur dioxide is converted to sulfur trioxide, and so oxygen is also needed, so air is further passed here. But as this is an equilibrium reaction, we need to maintain the conditions. Now, what are the conditions needed for such equilibrium reaction to get the maximum yield of sulfur trioxide? And to know the equilibrium reactions, equilibrium conditions, we need to know that the forward reaction is exothermic reaction. If the forward reaction is exothermic reaction, we need to maintain low temperature, because the higher temperature, lower will be the yield. But very low temperature will decrease the rate of reaction. So an optimum temperature of approximately 450 degrees Celsius is used. That's the temperature maintained for this equilibrium reaction. Other than that, the catalyst, most important catalyst is V2O5, that is vanadium thioxide. Vanadium thioxide is used as a catalyst in this reaction, and you can see here these are the plates of V2O5, which are perforated plates fitted inside the converter. These plates, which is coated with V2O5, from here the sulfur dioxide gas is passed along with the oxygen, which will help sulfur dioxide to convert into sulfur trioxide at a faster rate. Catalysts are meant for increasing the rate of reaction. It's not going to impact the yield, not going to impact the amount of product. So to increase the rate and make the process more economical, increasing the rate is one of the important thing, because it makes the process economical. So here V2O5, vanadium thioxide, is used as a catalyst. Now the next important factor to be maintained in an equilibrium reaction is a pressure. Now pressure is decided by the number of molecules on both sides of the reaction, and we can see that here 2 plus 1 molecules, that is total of 3 molecules, are present on the reactant side, and on the product side we have 2 molecules of sulfur trioxide. That shows that the number of molecules on reactant side is greater than on the product side. And according to equilibrium, that is Le Chatelier's principle, says that the side with fewer number of molecules will be favored by high pressure. So if you want to get a higher yield of sulfur trioxide with lower number of molecules, higher pressure should be used. But still, in this process, only the pressure of 2 atmospheric pressure is used. So let me add that here 2 atmospheric pressure is used, and the reason for this is that even at lower pressure of 2 atmospheric pressure, just higher than the room temperature, room pressure, economical yield of 98% sulfur trioxide is obtained, which is good enough. And so maintaining higher pressure than this makes the process even more uneconomical, because maintaining high pressure is costlier also and difficult also, because it may be dangerous. So for this equilibrium reaction, the conditions are 450 degrees Celsius temperature, catalyst vanadium thioxide, and pressure to atmospheric pressure. Right, so these are the conditions needed to get a good economical yield of sulfur trioxide. Now once the sulfur trioxide formed is then changed, is passed to sulfur trioxide. Sulfur trioxide is passed to a converter called absorber. Absorber is another compartment. Now here sulfur trioxide is then absorbed into 98% concentrated sulfuric acid, where some sulfuric acid is already present in the absorber. Now why is this done? Sulfur trioxide can be directly reacted with the water to get sulfuric acid, but this is not done. The reason being is that this process is very highly exothermic, and so the sulfuric acid obtained this way is going to be formed in the form of fine mist. Fine mist will be formed for the sulfuric acid obtained directly by reacting it with water. Now this is very difficult to condense, and the mist may be very dangerous because it may be spreading into the environment around the industry where it is produced. So to avoid this danger part, the danger process, sulfur trioxide is first absorbed into 98% sulfuric acid. Now this process, the process of sulfur trioxide getting absorbed in 98% sulfuric acid, it's going to produce another thick liquid called oleum. Now thick liquid oleum is H2S2O7. This is oleum. Oleum is less dangerous and it's a thick liquid, another form of sulfuric acid. So here in this H2S2O7, that is oleum, is produced in the absorber. This oleum then further is diluted with water. So a water is added in the oleum then further to get the sulfuric acid whenever needed. So sulfuric acid is lastly obtained by mixing oleum with the water. So this is the process by which we get the sulfuric acid, and the sulfuric acid obtained this way is 98% concentrated. So this is how we use contact process to get the sulfuric acid, where there are three stages. First is combustion. Second one, the sulfur dioxide is converted to sulfur trioxide. Then the sulfur trioxide is absorbed into 98% sulfuric acid to get oleum, and then oleum is further diluted with water to get the sulfuric acid. Now let's take the list of the reactions of contact process. So the first reaction taking place in the contact process is combustion of sulfur with oxygen to get sulfur dioxide. Sulfur dioxide is then further oxidized to get sulfur trioxide, and as we know, this reaction is an equilibrium reaction, so let me add a reversible sign here. The next stage of reaction here is sulfur trioxide is absorbed into 98% sulfuric acid to get oleum. So I can add 98% sulfuric acid to get the oleum. And the next and final reaction is that oleum is diluted with water to get sulfuric acid. So these are the important reaction to remember for the contact process. And this is how we are going to discuss that how contact process is used to make the sulfuric acid, one of the important chemical of the worldwide uses.